Hello viewers, welcome to my channel Online Biology Tutorials. In this live of today, I will be reading chapter 3 Electricity Circuits and their Components. This chapter is taken from the science book of class 7 CBSE board and the name of the book is Curiosity. As the screen is clear to you and in case the if your interest is there in reading the earlier two chapters, you can hear the audio of these two chapters, the playlist is already being uploaded. As the screen is clear, so let's go ahead and read this. Nihal and his classmates were excited for their school trip to the Bhakra Nangal Dam. There, they would visit the hydroelectric powerhouse where the force of falling water was used to generate electricity. They also looked forward to the free 13 kilometers train ride from Nangal in Punjab to Bhakra in Himachal Pradesh, along the beautiful Satluj River and through the Shivalik Hills. Prior to the trip, Nihal and his classmates were given a group assignment to prepare a presentation on the uses of electricity. They began by looking around their houses, then their school, followed by their neighborhood, their city, and finally they searched the internet. To their astonishment, their list kept growing. They decided to organize the uses under different headings. So, for cooking, they wrote electric kettle, mixer grinder, toaster, oven, microwave. For lighting, they wrote homes, offices, streets, markets, factories. For transportation, the uses they wrote were train, bus, car, scooter, lift, escalator, heating and cooling, fan, room heater, immersion rod, geyser, refrigerator, air conditioner, etc. For entertainment, they wrote television, radio. For communication, mobile phone, internet. Others, water pump, crane, and computer. Students, in case you feel doubt in any of the topic, you can write me in the comment section and I'll get back to you. Once you are done with the chapter, it is always good to hear the audio because this helps in increasing your knowledge and simultaneously a chapter is prepared from multiple books, so if anything new concept is given in a particular book, that is also prepared. I hope you know that at your level competency based questions come. Competency based questions are those in which the theory concept is used indirectly, but directly you won't be able to understand, right? So you can get back with me in the comment section in case of doubt. Can you help Nihal by adding some more uses to his list? Also suggest some other ways of grouping the uses of electricity. We use electricity all the time, so let us learn something more about electricity. You have learned earlier that electricity is generated in multiple ways by windmills, by using wind energy, by solar panels capturing the sun's energy, by falling water, and by using natural gas or coal. In the chapters Nature's Treasures in the classic science textbook Curiosity, the electric supply from these sources reaches our homes and factories via wires. For example, at home we plug in various devices to the electrical sockets in the wall. However, to learn about electricity, we will focus on a portable source of electricity that most of us may have used. Let us start with its use in a common device like a torchlight. Caution. The danger signs on electric poles and other appliances warn people that electricity can be dangerous if not carefully handled. Never ever perform experiments with power supply at your home or school. Even electricity from portable generators can be dangerous. Use only batteries or cells like those in the torchlights, wall clocks, radios, or remotes for experiments with electricity. 3.1a Torchlight. You might have used a torchlight, also called a torch or a flashlight. Activity 3.1. Let us explore. Take a torchlight similar to the one shown in figure 3.1. This one. Observe it carefully. Do you notice a lamp and a switch? Slide its switch and observe. Does the torch lamp glow? Now slide the switch back to its original position and observe the torch lamp. You might have noticed that in the first position of the switch, the torch lamp glows, and in the second position, the lamp does not glow. Now open the torchlight. What do you find inside? Inside the torchlight, you may find two or more electrical cells. Electric cells. Why does the torch lamp glow in one position of its switch? 3.2a. A simple electrical circuit. To understand how a torch works, let us first find out about its component. 3.2.1 Electric cell. Activity 3.2. Let us observe. Take an electric cell, turn it around and look at it carefully as shown to you in figure 3.2 means this one. Do you notice a positive plus sign and a negative minus sign marked on the electric cell? Do you also notice that it has a small protruding metal cap on one side and a flat metal disc on the other side? All electric cells have two terminals. One is called positive while the other is negative. The metal cap is the positive terminal of the electric cell and the metal disc is the negative terminal. The electric cell is a portable source of electrical energy. 3.2.2 Battery. Activity 3.3. Let us experiment. Take a torch which uses two cells, open its cell compartment and take out the cells. Put the cells back in a different order. Also try reversing the direction of one cell. Then slide the switch and check whether the lamp glows in each case. Check the order in which the cells were placed in the torch when the lamp glows. The lamp glows when the cells are placed in the order as shown in figure 3.3. So this is the circuit being shown to you in 3.3. Here they have shown you with two batteries. Here they have shown with the four batteries. See, it is plus minus alternating with each other. So in case if you place the cell this side, the torch will not glow. Notice how the terminals of the two cells are connected. The positive terminal of one cell is connected to the negative terminal of the next cell. Such a combination of two or more cells is called a battery. So whenever you are connecting two or more cells, it becomes a battery. One is known as cell. For many devices, we may need more than one cell. So we connect two or more cells together as shown to you in figure 3.3. We connect two or more cells together as shown in figure 3.3. Connecting more than one cell provides energy to the circuit for a longer time and or more energy. Fascinating facts. The term battery is also used for a single cell. We use the term battery even for a single cell that powers our mobile phones, right? So 3.2.3 electric lamp. Incandescent lamp. Activity 3.4. Let us observe. For this activity, you will require a torchlight with an incandescent lamp or a light bulb. Many old torchlights still use such lamps. With your teacher's help, confirm that your torchlight uses an incandescent lamp. So here is a small incandescent lamp used in the torch has been shown to you in A. This is the filament. This is the glass bulb. This is the thick wire here. Insulator. Insulator at the bottom. Metal case other than terminal. This is metal tip, one terminal, and there is a thick wire inside. For this activity, you will require a torchlight with an incandescent lamp or light bulb. Many old torches still use such lamps. With your teacher's help, confirm that your torchlight uses an incandescent lamp. Take a torch and examine its lamp. What do you see? Do you notice a thin wire fixed in the middle of the glass bulb? Now switch on the torch. Which part of the lamp glows? The thin wire inside the glass bulb of the lamp glows. The glowing thin wire is called the filament of the lamp. Take out the lamp with the help of your teacher and inspect it from all sides. How is the filament fixed? The filament is attached to two thicker wires that support it as shown in figure 3.4a. One thick wire connects to the metal case at the lamp's base while the other connects to the metal tip at the center of the base. Figure 3.4b. These form the two terminals of the lamp and are fixed in a way that they do not touch each other. In such incandescent lamps, the filament gets hot and glows to produce light. So this boy is thinking, however, my torch has a different kind of lamp. In fact, it cannot be taken out of the torch as it is fixed in it. So Here is its simplified drawing showing the connection of the wires to the terminal. So this they have shown the incandescent lamp here. Then next part, LED lamp. Many torches in use today have a light emitting diode or LED lamp instead of an incandescent lamp as shown in figure 3.5. So this is LED lamp. Activity 3.5, let us observe. Take an LED of any color and observe. Do you see any filament inside it? Notice the length of the two wires attached to the LED. Do you find one is longer than the other? So the one which is longer is the plus side and the other one automatically becomes negative. So here they have shown with the help of different LEDs. This is red, blue, transparent, yellow, and green. The longer leg is the one which is positive terminal, the other side is negative. Unlike incandescent lamps, LEDs do not have filaments as shown to you. They also have two terminals. One is positive attached to the longer wire and the other is negative with the shorter wire. A torch may use one or more LEDs, sometimes of different shapes in its lamp. After having learned about the electric cell, battery, and electric lamps, we are now ready to make the torch lamp glow using an electric cell or battery. 3.2.4, making an electric lamp glow using an electric cell or battery. Activity 3.6, let us construct. Take an electric cell, an incandescent lamp used in a torch, a cell holder, a lamp holder, and four lengths of electric wire. Remove about 1 centimeter of the plastic covering from both ends of each wire to explore the metal. Attach two wires to the two ends of the cell holder as shown in figure 3.7a. So here, whatever they have spoken, they have written here. So in A, this is electric cell holder with two wires attached. This is electrical cell inside the cell holder. Wire attached to an electric cell using the electrical tape. So these two wires are attached and this is the cell holder because it is holding the cell. Insert the cell in the holder such that its negative terminal is towards the spring side of the holder as seen in figure. In case a cell holder is not available, fix the two wires to the cell using the electrical tape. So in case holder is not available, you can directly attach the wires, one to the positive side and one to the negative side. Attach two wires to the screws of the lamp holder as shown in figure. So you will be attaching a screw. Fix the lamp in the holder by turning it around the holder. In case the holder lamp is not available, use electrical tape to attach two wires to the two ends of the lamp. Now we are ready to connect the cell to a lamp to make it glow. We will conduct this activity in two parts, prediction and observation. Some of the ways in which the lamp and the cell can be connected are shown in table 3.1. Predict for each arrangement if the lamp will grow or not and write your prediction in the table 3.1. Now connect the lamp and the cell and observe if the lamp glows or not. Note down your observation in table 3.1. Also for the lamps which glow, color their glass pulse yellow. So this is the table that you are required to fill. These are your observations that you are required to take. The lamp glows in the arrangement at serial number 1, 6 and does not glow in the remaining arrangements. Now carefully look at the arrangements in which the lamp glows. Compare these with those in which the lamp doesn't glow. Can you find the reason for the difference? 3.2.5, an electrical circuit. The lamp glows when one terminal of the lamp is connected to one terminal of the electric cell and the other terminal of the lamp to the other terminal of the cell as shown in figure 3.9. This setup forms an electrical circuit which provides a complete path for electric current to flow through the lamp. The lamp glows only when current passes through the circuit. The direction of the electric current in an electrical circuit is taken to be from the positive to the negative terminal of the electric cell. When the terminals of the lamp are connected with those of the electric cell by wires, the current passes through the filament of the incandescent lamp and makes it glow. With an incandescent lamp, it does not matter which of its terminals connect to the positive or negative terminal of the cell. The lamp will glow as long as the circuit is complete and the current flows through the filament. Fascinating fact. Sometimes an incandescent lamp does not glow even when connected to a cell. We say the lamp has fused usually due to a broken filament. A broken filament stops the flow of current, preventing the lamp from glowing because the circuit is broken, right? You might have heard of that the filament is broken in the bulbs also. So once the filament is broken, the circuit is broken. That is why the current does not flow. Let us now try to make an LED glow. Activity 3.7. Let us experiment. Take two electric cells and LED of any color, a cell holder that can fit two cells, and two lengths of electric wire. Remove about 1 centimeter of the plastic covering from both ends of each wire to expose the metal. Connect the two wires to the cell holder as shown in figure 3.10a. So this is the diagram that you need to follow. Insert two cells in the holder, taking care that for each cell its negative terminal is towards the spring side of the holder and the battery is ready to use. How will you decide which is the positive terminal of this battery? The terminal of the holder which is connected to the positive terminal of one cell is positive and the other connected to the negative terminal of the other cell is the negative terminal. Now connect the free end of the battery positive terminal wire to the longer wire of LED and the free end of the second wire to the shorter wire of the LED. Does the LED glow? Repeat the above step but interchange the wires connected to the LED. Does the LED glow again? You would have observed that the LED glows in the first case and does not glow in the other. It is because the current can pass through the LED in one direction only. The current passes through the LED only when the positive terminal or the longer wire of the LED is connected to the positive terminal of the battery, and the negative terminal or the shorter wire of the LED is connected to the negative terminal of the battery. When current passes through the LED, it glows. Always take care to connect an LED correctly in a circuit and make it glow. Dive deeper. Sometimes you may have come across a device in which the cells are placed side by side. Then, how are the terminals of the cell connected? If you carefully look inside the battery compartment, you will usually see a thick wire or metal strip connecting the positive terminal of one cell to the negative terminal of the next. To help with proper placement, plus and minus symbols are typically printed inside. 3.2.6 Electric switch. Let us first make a simple switch on our own. How does a switch turn on or off the torchlight? Activity 3.8. Let us construct. Collect two drawing pins, a safety pin or a paper clip, two wires, and a small piece of cardboard. Insert a drawing pin through the ring of the safety pin and fix it to the cardboard piece, ensuring that the safety pins can rotate freely. So, this is how you can consult images also. Fix the second drawing pin to the cardboard piece so the free end of the safety pin can touch it. Connect a wire to each drawing pin. Our switch is ready. Let us now test our switch. Activity 3.9. Let us test. Connect the electric cell, lamp and a switch as shown in figure 3.8a. Does the lamp glow? Rotate the free end of the safety pin till it touches the other drawing pin as shown in figure 3.8b. Does the lamp glow now? When the safety pin touches both drawing pins, it closes the gap and completes the path and allows the current to flow. We call this the on position, where the circuit is closed and the current flows from the cell's positive to the negative terminal, making the lamp glow. When the safety pin does not touch the second drawing pin. The gap in the circuit prevents current flow and the lamp does not glow. In this off position, we say that the circuit is open. Note that a switch can be placed anywhere in a circuit. A switch is a simple device that either completes or breaks a circuit. The switches used for lights and other devices at home work the same way though they are designed differently. So circuit diagrams are given in 3.3. can we represent the circuits in a simpler manner? The various components of an electric circuit can be represented by symbols. So electrical component, if you are using an electric cell, the symbol is this. So longer one is plus and the shorter one terminal is negative. And this is how the cell has been placed. This is plus, this is minus. So this longer arm is plus, this is minus. If you are using a battery, so two cells are there. This is plus, minus, plus, minus. So here also longer arm is plus, minus, plus, minus. For the electric lamp, you have to use this signal. For light emitting diode or LED, you are supposed to use this type of symbol. Switch in on position, you'll be using this. Switch in off position, you will be using this. This signifies that it is open, right? Wire ke liye you will be using this straight line. In the symbol of an electric cell, the longer line represents the positive terminal while the shorter one represents the negative terminal. So they are talking about this. Longer one positive, shorter one negative. In the symbol of an LED, the triangle points to the direction in which the current can flow. The two arrows indicate that light is emitted by an LED. By using symbols to represent electrical components, it is easier to draw and understand electrical circuits. A representation of an electrical circuit using symbols is called its circuit diagram. So, students, till 8th, you will be reading physics, chemistry, and biology in your one book only. In ninth and 10th, also, you will follow the same trend. But till class 8th, you had one teacher. In class ninth onwards, you will be having different teachers. So, this part of this electricity chapter, it comes under physics. So, in case this seems interesting to you, that means you are interested in physics more. Activity 3.10. Let us draw. Using symbols shown in table 3.2, draw the circuit diagram of an electrical circuit given in figure 3.12a and figure 3.10c. Are your circuit diagrams similar to figure 3.14a and figure 3.14b respectively? So this is the circuit diagram given for this incandescent lamp and this is for the LED. International organizations such as the International Electrotechnical Commission (IEC), American National Standards Institute (ANSI), and the Institute of Electrical and Electronics Engineers (IEEE) create standard symbols for electrical and electronic parts. Using the same symbols across the world helps people from different countries and industries understand each other easily. 3.4. Electrical conductors and insulators. Why did we use metal wires for making electric circuits? Can we not use some other material for wires? Also, why are electric wires covered with plastic or rubber? Suppose we make wires of materials other than metal and use them for making the electrical circuits. Do you think the electric circuit will pass through those materials in such a circuit? Activity 3.11. Let us identify, connect an electric cell and a lamp while leaving the two ends of wire free as shown in figure 3.15a. Touch the two free ends of the wires momentarily. Does the lamp glow? If yes, our tester is ready. We can use this tester to identify the materials through which electric current passes. Collect objects of different materials such as metal spoons, coins, cork, rubber, glass keys, pins, plastic scale, wooden block, aluminium foil, candle, sewing needle, cardboard, paper, and pencil, lead. One by one, touch the free ends of the tester wires to both ends of each object you have collected. Make sure the wires don't touch each other. Does the lamp glow even more? So you need to write whether the lamp glows or whether the lamp doesn't. So all the things that will allow the lamp to glow will be good conductor of heat and electricity. And you might have read in grade 6 about metals. Metals behave like this. Analyze your observations. Did the lamp glow for all materials? The lamp glows for some materials only. This means that electric current can pass easily through some materials but not through others. The materials through which electric current can flow easily are called good conductors or good conductors of electricity. The materials through which the current cannot pass through are called insulators or poor conductors of electricity. Based on the observations you have recorded in table 3.3, conclude which materials are conductors of electricity and which are insulators. From your conclusions in table 3.3, you would have realized that metals are conductors of electricity and thus are used for making wires. Dive deeper. Silver, copper, and gold are the best electrical conductors. However, for making electrical wires, mainly copper is used due to its comparatively lower cost and abundant supply. Different types of electrical wires are used for different uses. From table 3.3, you would have also realized that plastic, rubber, and ceramics are electrical insulators. Have you now understood why wires are covered with those materials? So, conductors and insulators are both important. Electrical wires, switches, connectors of plugs, and sockets are made up of conductors. Insulators like rubber, plastic, and ceramics are used to cover the wires, plug tops, and switches to protect people from electric shocks. Caution. Our body is a good conductor of electricity. Electric current passing through our body may cause severe injury or even death. Always handle electrical appliances with care. Never touch switches or plugs with wet hands, or use electrical devices in wet areas, or handle equipment with damaged insulation or broken plugs. Dive deeper. Have you ever wondered how the electricity from a cell or battery is different from the electricity coming from a wall socket? Electricity from batteries usually powers small devices and is of a type called direct current or DC. In contrast, the electricity from power plants that come to the wall socket is known as alternating current or AC and can run larger appliances. So, this is the summary of the electricity chapter. Whatever book you might be using at your school, you can always hear to the audio of this book, Curiosity. It will be helpful to you. An electric cell is a portable source of electrical energy. An electric cell has two terminals. One is called positive while the other is negative. In an incandescent electric lamp, there is a thin wire called the filament which gets hot and glows to produce light when electric current passes through it. An LED has two terminals. One is positive attached to the longer wire and the other is negative, the shorter wire. Electric current can pass through LED in one direction only, and LED lights up only when its positive terminal or the longer wire connects to the positive terminal of the battery, and its negative terminal shorter wire connects to the negative terminal of the battery. A switch is a simple device that either completes or breaks a circuit. The direction of electric current in a closed electrical circuit is taken to be from the positive to the negative terminal of the electric cell. A representation of an electrical circuit using symbols is called its circuit diagram. Materials through which electric current can flow easily are called good conductors or conductors of electricity. Materials through which current cannot pass through are called insulators or poor conductors of electricity. So these are the questions. You can practice these questions on your own. I'm scrolling it slowly so that you can take the screenshot or you can pause the video and practice at your own end. And in case you feel problem in any of the question, you can message me in the comment section. So these are the exploratory projects which you can explore and prepare on your own. So whichever book you are using at your own school for class 7 science, you can do revision with the help of this book. This is Curiosity Book of Science class 7 prescribed by the CBSE board. So we are done with the reading of chapter 3, class 7 science, and the name of the chapter is electricity circuits and their components. In case you are interested in hearing the audio of first two chapters, a playlist has already been uploaded. Stay connected. See you in next video. Thank you.